Hello, good evening everyone. So this is going to be your grade 10 term 2 math ETA reviewer. And yeah, I may sound a bit tired, but I had very fun for 3 days. It was my birthday from December 5, and then we celebrated from the weekend. So, yeah, it's 11:45, December 7. I'll be recording unit 1 for tonight from here to here. Yeah, here to here. And then the rest I'll record tomorrow. So this first unit is all about probability. So the number one rule of probability is if you convert the fraction you get to a decimal, it should always be between 0 and 1. Where 0 means it's impossible and 1 is certain. So 0.5 is like, okay, 50-50. And then like 0.2 is like probably not gonna happen. 0.8 is like, uh, yeah, it's probably gonna happen. So there are a few terms that can get mixed up here. So number one is the experiment. Experiment is a situational activity involving chance. So let's, for example, rolling a die. So that involves chance because there's multiple sides of the die, and it can land in any one of them. Now the outcome is the result of an experiment. So what can be your possible outcome? It can be 2, it can be 6, it can be 3. And then the sample space is the list of possible outcomes, and it's usually notated like this. So S is equal to curly bracket and then all of this. So 1, 2, 3, 4, 5, 6. And then the event is a subset of a sample space. So let's say out of this sample space we want even numbers only. So even numbers are E is 2, 4, and 6. So these are the different terms that you need to know in order to understand probability. Okay, now there's two types of probability we have here. This is the experimental and theoretical. So experimental is through the trials, meanwhile the theoretical is through calculations. So let's say we roll a dice 100 times, and then let's say we get this table over here. That's what we call experimental outcome. And let's say we want, based on this data, we want to see what's the chances of getting a 3. So a 3 in this case is 21. So the answer for, let's say, chance of getting 3 is 21 over 100. So trials or experimental probability is more on analyzing the tables and what's given to you. If you want even numbers, just add the 2, the 4, and then the 6. Then you get your answer. If you want odd, add up the odd numbers. You just need to analyze the problem, and then it'll be very simple. Now, how about the theoretical probability? Now, theoretical probability involves you you don't want to do any trials, you just want to go by the facts over here. So what's the chance of getting a 2? So we want our favored outcomes, favor over total. So obviously we know total outcomes is 6. Possible outcomes is 6. But how many favorable outcomes do we have? How many 2's do we have over here? We have 1. So therefore our answer is 1 over 6. So here are some more card examples, so that, because yes, probability is often involved with cards. So remember that there's 13 unique characters. There's an A, and then numbers 2 through 10, and then Jack, Queen, and King. Remember that Jack, Queen, and King are also face cards. So if you ever come up with that term on the test, you know what it is. So there are 4 suites. I've already colored them. The spades, the clubs, the diamonds, and the hearts. So these are the black ones, and these are the red ones. So some examples are, a red card is 1/2, because as you could see, out of all the 4 suites, there's 2 of them. So 2 over 4, or 1 over 2. Then a queen card. So queen card is one of the 13 unique characters. So since there's just one queen, there can only mean that 1 over 13 is the correct answer. And then a spade card. A spade card is one of the 4 clubs. It's this one, I think. And then, yeah, well, if you're asked for a certain, like, club, it's 1 in 4. So in this case, this is 1 in 4. So that's an example of experimental and theoretical probability. Next, simple and... Okay, I just realized there's no simple and compound events, but it's probably gonna pop up. So let's just cover it to be sure. So simple versus compound events. So let's consider this example. A box contains 4 red balls, 5 yellow balls, and 3 green balls. If a ball is picked at random from the box, find the probability that the ball is picked is a yellow ball and a yellow or red ball. So a yellow ball is one type of favorable outcome, but compound event means 2 or more favorable outcomes. So that's just the gist of it. So if you're listing more than one type of favorable outcome, that's automatically a compound. But if it's not, then it's simple. So I guess let's try to solve for this one. So we have 4, 5, 3. So that's our sample space. We have 4 red balls, 5 yellow balls, and 3 green balls. So our sample space is 12. Then a yellow ball is 5. So therefore, 5 favorable outcomes over 12 possible. So that's 5 over 12. So that's the answer to this one. But how about a compound event? So you just solve it like a simple event, but since we have more than one favorable outcome, let's consider all of them. So we have a yellow ball. We still have 12 balls, obviously. So we have 5 yellow balls. But it's also acceptable for us that we get a red ball. So we have 4. Because 4 red balls and 5 yellow balls. So we add that's equal to 9 over 12 or 3 over 4. And that's the answer. Next, the union and intersection. So this is the Venn diagram. You've encountered it quite a lot, even in non-math terms. So in these two cells over here, this is what you call the differences. And then this one is the similarities. Similar to sets, they can share elements, but they also have their unique elements themselves. So union, if you're asking a problem, consider A or B. Or when you're drawing a Venn diagram, you shade this part. But if you're asked for the and B, A and B, you have to consider the intersection, which is just this part. Let's focus on that. Let's focus on that later. But usually this is usually used in mutually exclusive versus non-mutually exclusive. So if it's a mutually exclusive event, they have no intersection. So for example, an odd number and an even number. So there are odd numbers, of course, and there's even numbers. But unfortunately, we just can't pick a number that's both odd and even. That cannot be the case. If you're crazy, you could argue that's 0. Even 0 isn't odd or even, so yeah, nothing. So therefore, that example over here is mutually exclusive. But for non-mutually exclusive, there's an intersection. For example, getting an even number divisible by 3. So even number is 2, 4, and 6. Divisible by 3 is 3 and 6. So as you could see, they both have 6, which would belong in this intersection over here. So you could say that this sample scenario is a non-mutual. These two example scenarios are non-mutually exclusive events. Now, last term before we get to problem solving is dependent versus independent. So for dependent is when an outcome of one event alters the outcome of another. The keyword here is without replacement. We'll see later. And then for independent, it's when an outcome of one event does not influence the other. The keyword is with replacement. So let's try. This one, first and foremost, this one is a non-mutually exclusive event. Why? Oh, I mixed it up. Okay, you're not seeing anything. Okay, there. So mutually exclusive event. So why is this a mutually exclusive event? That means there's no intersection between drawing a 2 or 5 from a standard deck of cards. Let's prove that. So cards with 2 in it. So 2 is equal to the 2 of spade, 2 of spade, the 2 of club, and then the 2 of diamond, the 2 of heart. Okay, but for the 5, it's gonna be the 5 club, 5 of spade, 5 of diamond, 5 of heart. Now, as you could see over here, there are none of the two sets share a common probability. So since this is just a deck of cards, our sample space is 52. So we have 4 outcomes here and 4 outcomes here. So since this is aura 5, we can just do 4 plus 4 over 52, which is equal to 8 over 52, or just 2 over 13. So this is the answer. So next, non-mutually exclusive event. So non-mutually exclusive event. So we know that in a math class of 30 students, so let's list that down as our sample space. We know 17 boys, 13 girls, and then 9 of which are, okay, 4 boys and 5 girls made an A grade. So in total, 9 A grade. We want to find the probability that girl or A student. So what's the chance here? So first and foremost, we can list the girls. 13 over 30. And we can also list our A students. 9 over 30. And then right, you can just add them. No, because part of the 5 girls are part of the 13 total. So when you do a Venn diagram of this, let's say this is the girls, this entire region, right, this one must equal to 13. So we want, okay, let's use pink for the girls. So we have 13 in total, but we know that 5 girls made the A grade. So let's put 5 over here. So 13 minus 5 is 8. Because in total, 8 plus 5 is 13, which suffices this. Next, for the boys, we have 4 boys here. And we know that there's 17 in total. Right? So 17 minus 4 is 13. And now, we just need to shade the required region. We want the required region to be a girl or an A student. So we can shade the part na, sige, red. Okay, we can shade this part, so the 5 and 4, as well as the girls part 8, because we want A student or girl. So 8 plus 5, so that's why we do minus 5, because we might double count it. So we do minus 5 over 30 to get our final answer of 16 out of 30, or just, oh sorry, yeah, 17 out of 30. And that's our answer right there. Next, independent events. Okay. 2 cards are drawn from a standard deck of cards in succession with replacement. What's the probability of getting an ace, then a queen? So, it's with replacement. So, with replacement, your sample space is not affected or not changed. So, your sample space always, in this case, since a standard deck of cards is 52. So, we know an ace is one of the 13 unique characters. So 1 over 13. Then, we want a queen right after. So since we want the succession of events, we have to multiply. So 1 in 13 as well, because the queen is one of the unique characters. So if we multiply these together, is 1 over 169. And that's our answer. Okay. But what if we do the same question with without replacement? Now these things get a bit changed here. Now, okay. 2 cards are drawn from a standard deck of cards in succession without replacement. So we want to get an ace first, then a queen. So obviously, our ace still remains as 1 over 13. But what about our queen? Now the thing is, without replacement, so once you take the ace card out, it's not going to be going back, which means your sample space has changed. Because now there's not 52 cards in the deck anymore, there's 51 cards. But there are still 4 queens. So the answer to this is like this: 1 over 13 or 4 over 52. You can also use 4 over 52 times 4 over 51. And then when we do that, if you type that in the calculator, we get 4 over 663. And as you could see, these values are very similar, but they're not the same change. These situations are similar, but they have different answers. So we need to read the questions carefully. But other than that, that is how we illustrate the union and intersection. We illustrated the mutually and non-mutually, and we also illustrated the dependent and independent, as well as the solving union. We also solved the simple and compound probabilities. Oh, it's there pala. Okay, very nice. Good night, guys. It's midnight. I'll see you guys tomorrow when I get up, and I'll get right to work on Unit 2, which is just polynomials. Okay, good morning, everyone. So it's now next day. So our next unit is going to be part 1 of the polynomials, which I'll cover from here to here. And then the third part is now the solving part. So we're first on to the explanation, the terms. So let's start. So polynomial equation versus expression. So the difference is very clear. In equation, you have an equal sign, while in expression, you do not. So why does this matter? So if you have an equation, you have something to solve for. Like you need this expression, this one over here. You need to find the value of x that will result this in being 0. And in this case, the zeros are also called the roots. So you can find the roots here. However, in the expression over here, you can only evaluate because you can't solve for anything. You can't even graph it because there was no y-axis. So all you can really do is maybe try to find a pattern. Maybe this polynomial function results in maybe some sort of a logic pattern, something like that. Now, simplifying what are the rules of polynomials? So it cannot have the variable in the denominator, something like 1 over x. This is because if we want to solve for x, we have to flip the x, right? We have to flip we have to flip the fraction to get x. But the problem is this will result in -1 or something like that, which also violates another rule, which has negative exponents. Next is also variable inside a radical symbol. Once again, a recall from grade 9, if something like this, right? Now, the square root of x can be written as x raised to 1/2 because the exponent over here and the number over here. The reason why it's not shown is because square root is automatically second degree, and x raised to nothing is just x raised to 1. But as you could see, this also violates a non-integer exponent. And then we also have variable as an exponent. So it just looks like this, 5 over x. And lastly, the other non-integer exponents, x raised to 3.7, something like that. Now, if let's say you encounter an expression or equation that breaks one of these rules, then that's what you simply call an algebraic expression. It's not a polynomial. So to put things simply, algebraic expression is just a wider term, and polynomials are part of those algebraic expressions under these restrictions. This one. Okay, continuing. So to simplify some polynomials, we combine the like terms. So the like terms, you have to ensure that the letter is the same, and then we also have the exact same what do you call this, exponent. So in this case it's z. In this case it's z squared. So 8 squared minus 5z squared is just 3z squared, and then we just add the other terms plus 3x. And then we can also use the FOIL method. So first here, so 2x times 5x is 10x squared. And then outer, 2x times negative 8 is negative 16x. Then inner, 3 times 5x is 15x. And then last is 3 times negative 8. So that's negative 24. We get 10x squared minus 16x plus 15x minus 24. Or simplifying, we have 10x squared minus x minus 24. So we've done this one. We've done this one. We haven't discussed terms, but here's some more terms, okay? Here's some more key pointers. Next is the degree. It's the highest exponent. So after you expand this one, you have to what's this? Find the highest exponent. In this case, it's 2. So therefore, this is called a quadratic. So we have constant is 0, linear 1, quadratic 2, cubic 3, quartic 4, and quintic 5. There's more terms above 5, but you don't need to memorize them. And by terms, so remember, after simplifying, right, these are terms. This one. So in that case, this is 2 terms. So it's a binomial. So we have monomial, binomial, trinomial, and multinomial. So standard form, you need to arrange the terms from their exponents. So from highest all the way to lowest. That's basically it. And then another one is numerical coefficient versus literal coefficient. Literal coefficient is just like the letter and the exponent, so x cubed. Numerical coefficient is the number that's attached to that. If there's no number, it's just 1. But in this case, it's 15. So this is, we already did this. Degree of the number of terms, degree of the terms. Okay. So let's just have a quick here. So number of terms is just the number of this. So in this case is 2. Then degree of the term. So we can take any individual term. So let's say this one. And degree of the term is just this one. So it's 2. And lastly, but the term of the entire polynomial is the highest one. So in this case, it's 3. Okay. Alright. So that's basically it for the explanation part. That's pretty quick. I'll now move on to the long and synthetic division. Okay, next we go to the division of polynomials. Okay, so let's get started. Okay, first we have long versus synthetic division. Long division is similar to dividing a integer or any number. If you remember from grade school, you have like let's say 3 divided by 100, and then you have to like 1 times 3, that's 3 times like 10, so there's no 1, so 10. So 10 divided by 3. 3. 3 times 3. 9. And then 1, 10. Then 10 divided by 3 again. So 10 divided by 3, that's divide. Okay, so 3. 3 times 3, that's multiply. 9. Then subtract 1. And then bring down. But in this case, we have R1. Now, long division is very similar to that. And I'll show you how to do it. So let's try to divide negative 12 plus 2x plus x squared by x minus 3. Now, the first thing you want to do is you need to make this equation here, both your dividend, this one dividend, and divisor in standard form. So, good thing this one's already in standard form. But here, we need to rearrange it. So, negative 12 obviously goes last because it's the lowest, it's the constant. Then, followed by 2x. Then, plus x squared. Now, we're ready to do the long division. So, obviously, you draw the same structure that you want to draw. Let's just erase this so we have more space. And move it here. X minus 3. So, let's see this. So first and foremost, what do? We need to take x squared. We need to take x squared divided by x. That's just x. Now, we need to multiply x by x minus 3. So that's x times x, x squared. X times negative 3, negative 3x. Okay. And then, we can cancel this one out. 2 minus 3x. 2x minus 3x is just negative x. So we have negative x now. Oh, sorry. No. Subtract. So 2 minus negative 3x. So that's the same thing as 2 plus 3x. 5x. Then bring down the next term, minus 12. Then we just repeat it. So 5x divided by x is just 5. 5 times x is 5x. 5 times negative 3 is negative 15. Subtract. 5x minus 5x, that's equal to 0. So cancel. Negative 12 minus negative 15 is the same as negative 12 plus 15. So it's just 3. Now, you have no more terms to bring down, but you still have this one. That's your remainder. And you can notate that as 3 over your divisor, x minus 3. And then just plus it. So the answer for this one is x plus 5 plus x plus 5 plus x 3 over x minus 3. Sorry about that. But let's say we have a special case here. What if we have, let's say some terms are missing, some degrees are missing. So we have divide. So example number 2, we have divide x cubed minus 2 by x plus 1. Now you see, of course it's in standard form, but we have a slight problem here. We have no x squared and x. Now, you can't just do that because it will result in an error. We still need like 4 terms. So what do? We just substitute with 0 until we have the complete list. So x cubed plus 0x squared plus 0x minus 2. So try to do this. So we still follow the same process. So x squared divided by x. X cubed divided by x is x squared, sorry. Then we have, we have x squared times x, that's x cubed. X squared plus 1 times 1x, 1, that's going to be just x squared. Subtract. So we can cancel this one out. We have negative x squared. Then we repeat. negative x squared divided by x is just negative x. Negative x times x squared, that's negative x squared. And then bring down this one plus 0x. Oh, sorry, no. Okay, return to this phase. So negative x squared divided by x is just, oh, bring down. Oh. But yeah, okay, try again. Negative x squared divided by x is negative x. Negative x times x squared, times x, sorry. That's gonna be negative x squared. And then we have negative x times 1, negative x. So this will cancel each other. And then we have negative 1x, or just negative x. Oh, sorry, x. Because 0 minus negative 1 is 1. There we go. Bring down the negative 2. Okay, last one. So we have to do x divided by x is just 1. 1 times x is x. 1 times 1, 1. Subtract. So we can cancel this one out. Negative 2 minus 1, negative 3. And that's our final answer. So negative 3 over x plus 1. And that's our answer. As you could see, it's very tedious, and even I myself get it screwed up. But what if there's a shorter way? That's why we have synthetic division. And it can be used when we need to do this division multiple times to find the roots. So let's try again. So first we need to list down the numerical coefficients. So same thing. So we have 1, 2, and negative 12. So, okay. And then we need to equate this to 0. So x minus 3 is equal to 0. So x is equal to 3. So that's gonna be our divisor. Then, first, bring down 1. Then, 1 times 3. Yeah, 1 times 3 is 3. Add. 2 plus 3, 5. 5 times 3 is 15. And then, add this one is negative 3. Oh, sorry, positive 3. Now you got 1, 5, and 3. Your last term is always your remainder. And your first term is always 1 degree less than your initial. So this is now from quadratic, x squared is now linear. So it's 1x plus 5 with a remainder of 3 over x minus 3. As you could see, if after translating, it's still the same. And then you can also apply the same logic to when there's missing a variable. So in this case, x plus 1 is equal to 0. So x is equal to negative 1. So we just put the same thing. 1, 0, 0, negative 2. We do the same process. 1. 1 times negative 1. Negative 1. 0 plus negative 1, negative 1. Negative 1 times negative 1 is 1. This is 1. 1 times negative 1 is negative 1. And then if you add this, negative 3. Remainder. So we started from cubic. Therefore, this is a quadratic. So x squared minus 1 minus x plus 1 with a remainder of negative 3 over x plus 1. So, as you could see, both of these have remainder. And you can actually use this. You can actually make x equal to 0 in your divisor. As you could see, negative 1. And then you can just evaluate this one. You can evaluate the polynomial with x is equal to -1. And that will give you -3. So that's what you call remainder theorem. Now, however, if you do the same thing, and let's say, so evaluate at x equals, okay, let's do this. X equals, so as you could see, if it's equal to 0, then it's called factor. That's factor theorem. If not equal to 0, that's called remainder. So they're doing the same process, but it just has a different term. They're essentially the same process, but that's how you do the remainder and factor theorem. So if you're asked quickly just to find if it's a factor or not, just equate the divisor to 0, substitute the value of x, and then evaluate. So you'll be allowed the calculator so that you can solve it quickly. Okay, so we haven't covered factoring and root and everything, so I will just take a break and then I'll catch you guys later. Okay, next I have about polynomial factoring. So there's a lot of theorems to discuss, so let's just go over them. So first is the fundamental theorem of algebra. A polynomial with degree n has n roots. So basically, highest degree is the amount of roots you have. Meanwhile, the zero product property is that if a, b is equal to 0, then at least a or b or both of them is also equal to 0. Then we got the rational root theorem, L over F, where the factors of the last constant over the first that's the leading coefficient, is the factors. Then the multiplicity just states that a polynomial may have multiples of the same roots. Quadratic surd, in the other hand, is if x plus y is a root, then x minus square root of y is also a root. Similarly, complex conjugate, if a plus bi, where imaginary unit, is a root, then a minus bi is also a root. So let's try to solve using this. So first one, try this one. Upper bound and lower bound. So upper bound is that after long division, we have a remainder and it's all terms positive. But the lower bound is after long division has remainder and alternating signs. This is negative, by the way, and this one's positive. Okay, first, let's try this first one. So by FRT or FTA, this has the highest degree is 3, so 3 roots. Next, RRT, factors of 6 over factors of 1, so just factor of 6 is plus minus 1, plus minus 2, plus minus 3, plus minus 6. Now let's try to use, let's try to use upper lower bound. Let's start with an upper bound. Let's try our upper bound is 2. So we have 1, 6, 11, 6. Then we want our upper bound to be 2, so we put it there. Bring down 1. 1 times 2, that's 2. 6 plus 2, 8. 8 times 2, 16. 11 plus 16, 27. 27 times 2, 54. And 6 plus 54 is 60. Now, all terms are positive. Check. And we have a remainder. So if 2 already is this large of a remainder, what more if it's 3 or 6? So therefore, 2 is an upper bound. How about a lower bound? Lower bound, let's try. Lower bound, maybe, let's try negative 6. Okay, negative 6. It's on the extreme end, but at least let's try to eliminate one root so that we are slightly faster. So negative 6. We want 1, 6, 11, 6 again. And then we have 1 times negative 6, negative 6. 0. 0 times negative 6, 0. 11. So 11 times negative 6, negative 66. 6 plus negative 66 is negative 60. So negative 6 is lower bound. So why is it lower bound? As you can see, alternating signs, but we have 0 here. So it can be act as negative. So that positive, negative, positive, negative. Positive, negative, positive, negative. Okay. That leaves our possible roots as negative 3, negative 2, negative 1, and 1. Okay, let's try negative 3 first. So 1, 6, 11, 6. Okay. Bring down 1. 1 times negative 3. Negative 3. 6 plus negative 3. That's 3. 3 times negative 3. That's negative 9. 11 plus negative 9 is 2. 2 times negative 3. Negative 6. 0. Now, since this is originally a cubic, we can translate this into a quadratic, which is x squared plus 3x plus 2. Now, as you could see, you can easily factor this already, which means, so you have x plus 2, x plus 1. So by FOIL method, if you expand this, you'll get this back. So therefore, x is also equal to negative 2 and negative 1. Okay, let's see our total roots. So x is equal to negative 3, negative 2, negative 1. Okay, so no special cases there, as you could see. But let's try the second one. Okay. Okay, first one. So FTA, this also has 3 roots. RRT, so the roots of 27 are plus minus 1, plus minus 3, plus minus 9, plus minus 27. So let's try to do an upper bound first. Let's say it's 9. Okay, so you put 9 here. This is gonna be 1, 3, 9, 27. Oh, what am I doing? Sorry, it's 1, negative 9, 27, negative 27. So 1 times 9, 9. Negative 9 plus 9, 0. 0 times 9 is 0. So 27 plus 0 is 27. 27 times 9 is 243. Then if we add this together, it's gonna be oh wait, 216. Yeah, 216. But as you could see, so all terms are positive, so upper bound is 9. How about lower bound? Lower bound. Okay. Lower bound, let's try, you know what, let's be ambitious. Let's try negative 1. So lower bound is negative 1, so negative 1, and we put 1, negative 9, 27, negative 27. 1 times negative 1, negative 1. Negative 9 plus negative 1, that's negative 10. Negative 10 times negative 1, that's 10. 37. 37 times negative 1 is negative 37. Add this together. This is negative 64. So it's alternating signs. That means lower bound is negative 1. That means we have... Okay, we eliminated all the roots now, so that the possible roots is only one or three. But the problem now is we need three roots. That's where multiplicity comes in. A polynomial may have multiple of the same roots. So I don't think this is 1. Just look at it. You think this will equate to 1? No. It looks more on 3. So let's try to solve using 3. So we have 1, negative 9, 27, and negative 27. So we drag down the 1. 1 times 3, 3. Negative 9 plus 3, negative 6. Negative 6 times 3, negative 18. That's negative 27 plus negative 18, that's 9. 9 times 3, 27. 0. So we know that 3 is a root, and we have x squared minus 6x plus 9. This is a perfect square trinomial. So it can be factored into x minus 3 and x minus 3. So we have 1, 2, and 3. So therefore, your answer is x is equal to 3 multiplicity of 3. Okay, how about this one? Let's try to eliminate some. Now, how about this one? It's all cubics, by the way, so yeah, my bad about that. Okay, I hope you don't mind, guys. So, FRT, we know there's, again, 3 roots. And then, RRT, FTA, I'm getting my terms mixed up, FTA, RRT, we have factors of 10 over factors of 1, so just factors of 10. That's equal to plus minus 1, plus minus 2, plus minus 5, and plus minus 10. Okay. Let's look for our upper bound first. Upper bound, say 5. Let's try 5. So 5, and then we put the numbers 1, negative 2, negative 5, 10. 1 times 5, 5. Negative 2 plus 5, 3. 3 times 5, 15. Bring this down, negative 5, 10. Right? Yeah, 10. 10 times 5 is 50. This is 60. So upper bound, 5. Okay. How about lower bound? Lower bound, let's say negative 1 again. Let's try to eliminate all the negative. Okay. So negative 1. This is 1, negative 2, negative 5, 10. So 1 times negative 1 is negative 1. Negative 1 plus negative 2, 1. Negative 2 plus negative 1 is negative 3. Negative 3 times 1 is 3. That's equal to negative 2. Negative 2 times negative 1 is so 2. And then 12. Now, since it's not alternating signs, lower bound is not negative 1. Let's try negative 2 instead. So 1, negative 2, negative 5, and 10. 1 times negative 2, negative 2. Negative 2 times plus negative 2, negative 4. Negative 4 times negative 2, 8. Negative 5 plus 8, 3. 3 times negative 2, negative 2. Negative 6. Which is 4. Which is 4. So we have, okay, we still don't have alternating signs. Okay, hold on, wait. So it's still not repeating. So it means that, let's erase this. Let's try to do negative 5. So, negative 5. 1, negative 2, negative 5, and 10. 1 times negative 5, negative 5, negative 2 plus negative 5, negative 7. Negative 7 times negative 5, 35. Negative 5 plus 35 is 30. 30 times negative 5, negative 150. That's equal to negative 140. Okay, alternating signs. So lower bound is negative 5. So that leaves us our roots with this one lang. We have x is negative 2, negative 1, 1, and 2. So let's try 2. So 1, negative 2, negative 5, 10. We have 1 times 2, 2. Negative 2 times plus 2, that's 0. 0 times 2, 0. This is just negative 5. Negative 5 times 2 is negative 10. 0. Okay, perfect. We have a quadratic. Since it's cubic, we translate to quadratic. X squared minus 5. Sorry, x squared minus 0x minus 5. Simplify it, x squared minus 5. So we know that 2 is a root. But look at this, it's a square root. So let's equate it to 0. X squared is equal to 5. X is equal to square root of 5. And this is where quadratic third comes in. Plus minus. Because, yeah, plus square root and then minus square root. So this is also a root and then 2. This is your answer. Okay, last. Okay. So FRT, this is 3 roots. Oh my gosh, FTA, I'm getting them mixed up. Then RRT, 1, so 21, factors of 21 over factors of 1, so just 21 factors of 21, so plus minus 1, plus minus 3, plus minus 7, plus minus 21. Okay, no one will say 41, okay? No one will say 41. Okay, let's try to find our upper bound. Let's try 7. Wait. Oh, let's try 3. Okay. So 1, 3, 7, 21, 3. 1 times 3, 3. 3 plus 3 is 6. 6 times 3 is 18. 7 plus 18 is 25. 25 times 3 is 75. 75 plus 21 is 96. So this is an upper bound. How about our lower bound? Lower bound, let's try negative 7. So negative 7. 1, 3, 7, 21. 1 times negative 7, negative 7. So this is negative 4. Negative 4 times negative 7, 28. This is 35. 35 times negative 7 is 30. negative 245. And then if you add this together, this one becomes negative 224. So it's alternating sign, so this is a lower bound. That leaves our possible roots as x can equal to 1 or negative 3, right? Oh, 1, negative 1, negative 3. So let's try negative 3. Okay. So 1, 3, 7, 21. 1 times negative 3, negative 3, 0. 0 times negative 3, 0. 7 plus 0, 7. 7 times negative 3, negative 21, 0. So we know that negative 3, x is equal to negative 3. So x squared plus 7 is equal to 0. X squared is equal to negative 7. Oh no! You can't get a square root number, right? This is where the complex conjugate comes in. So we just square root both sides and add an I. So it means x is equal to plus minus plus minus I root 7 as well as negative 3. And that is all the theorems covered. So we factored the polynomial. We deter the 0. So to do this, you just have to make sure that there's no remainder after you do synthetic and long division. Then we covered all of this. We'll focus now on the application and graphs later on. I think I'm running out of time, so I have to go by like 11. So yeah, look at this. So actually just a review. Okay, so last problem. This is solving problems involving polynomials and polynomial equations. So this is actually functions, but it's basically the same thing. So the profit made in pesos from selling X notebooks is given by x cubed minus 15x squared plus 56x. So for letter A, we want to find if x equals 7. So this is equal to 7 raised to 3 minus 15 7 squared plus 56 7. Oh, I said it. Oh no, I said the forbidden one. Okay, well, to do this actually you can change the x value in your calculator to 7, and then you can just type this equation so that you don't have to manually type it. So after typing it, you get negative 336. Is that correct? Okay, so we get negative 336 pesos. So negative 336. So this is a term of evaluating, and yeah, this is just one of the ways we can use this function. Okay, sorry for that. It's actually, I forgot to put an it's 0. So what does the profit mean when 0? It's called break even. So letter B, solve for the number of notebooks that will result in 0 revenue. So you'll need to use the x squared. We need to use division here. So what we can do is, since it's still in descending order, we can just find two divisors that when you multiply them, when you add them together, it's negative 15, and when you multiply them is 56. And those divisors are 7 and 8, because so the roots are, yeah, so it's gonna be, how do we factor this? But yeah, it's the answers are 7 and 8, because when we evaluate them, okay, 7 is obviously one of them, and then 8, if we set this one to 8, 3 minus 15, 8 squared plus 56, 8, that's still equal to 0. So why is this the case? So for the first one is because the cost production, and this one is for another in like what do you call this? Yeah, profit. So like whenever you make in this type, right, it's usually a curve. So this is for the profit. And of course we also have 0, because since it's all multiplied, right, 0 product property. So the answer is 0, 7, and 8. And yeah, I just basically explained what's the context when profit is 0. It's either cost production or profit, or there's no production to begin with. So that's gonna be one of the examples you'll encounter. I'm sorry there's not much we can work with because we weren't given the slides. So the last thing to do is actually just cover the graphs, and then actually I don't even have a sample problem for this, so I'll just show you the graph transformations instead. So for the last part of the video, this is graph transformation. So we first start with the parent function. So parent function is x squared or x raised to any integer above 1. So we have x squared, x cubed, x raised to 4. So let's experiment first. So first and foremost, let's experiment with our first parent function. So let's say we want to do x plus k is equal to x plus k squared. So notice what happens if k is 0. As you could see, it's still in the right function, right? It's right in the 0, 0 point. But if we move the slider to the positive direction, it goes to the negative axis. Why? Because we want this to equal to 0. And if it's x plus 10 is equal to 0, by 0 product property, we must make sure that x is negative 10. So that when negative 10 plus 10, it's equal to 0 squared. So similarly, if we have a negative k over here, it goes to the right. Why? Because now that k is negative, so x minus 10 squared is equal to 0, we need to make sure that kx is positive, so that our positive and negative cancel each other out. So it's going to be 10 minus 10, which is 0. 0 squared, that's equal to 0. This is what we call the left and right shifting. Now watch what happens if we move the k. Let's look what happens if we make the k outside the parentheses. Wait, I need the plus there. So now k goes either up or down. Why is this the case? Because we're adding to the entire function, not just the parent function. We're just adding to the entire function in general. So that's why when we make k positive, it goes up. And if we make k negative, it goes down. This is called your up and down shifts. Okay. Next. So we have, let's say we have how about this? The negative reflect. So this is basically just look for the negative sign. This is the reflection property. If there's a negative sign in front of everything, it will just reflect on the x-axis. So as you can see over there, if I just remove and play around with the x-axis, that's gonna be it. Okay. And lastly, is the widening and the what do you call this? The widening and the what do you call it? Compressing, or what do you call this? Thinning or stretching. So let's say it's this is only for positive. So notice when we put this function, right? So we're playing with k. Hold on. So if k is equal to 1, you just get 1x squared. Sorry. Yeah, there. So 1. Notice how if I make the k larger, it becomes narrower. That is because we're multiplying the numbers together to the fact that it grows larger. Now, notice how if I slowly but surely approach 0, the function gets wider to the point where, as you could see, 0.1 here. It's because 0.1 is not a very large multiplier, and thus, for the x values to catch up with the y, they have no other choice but to widen that to equal the y. So that's the three types of transformations. So first we got the reflect shift, so here, and then we got the left right and up down shifts, which is like this one, so this is up down, and then this is hold on, this is gonna be left right, there, left right. And then lastly is the widening, which I just showed you. So that's basically all I can give for you given the time I have right now. So let's go back to the board. Unfortunately, we don't have any problems, but we do have the transformation of graphs, which is the best thing I can do. So yeah, there we go, guys. That's the first ETA down in a day, surprisingly. Actually, this is early release because it's supposed to release tomorrow, but I have my ways. I can go earlier. Birthday was great. Thanks for all the wishes, guys, and take care of yourselves. ETA is coming up, and I'll see you in the next one. Bye.